With the recent dangers of the coronavirus outbreak, as much as we wanted to participate in the summit, we would like to apologize for not being able to come. We hope that this video would suffice for project updates, and we hope for your kind consideration and understanding on this matter. Thank you. Now, our project is entitled Reef Patrol. Now, the Philippines is home to the largest coral species in the world. In fact, we have over 600 coral species in the Philippines alone. Compare that to only 400 species in the Great Barrier Reef and only 50 species in the Caribbean Sea. But despite these numbers, our coral reef health continues to decrease every year due to pollution, ocean acidification, and more importantly, climate change. And thus we are faced with three main problems. Firstly, how do we preserve coral reefs for marine biodiversity? And even if we were able to preserve our coral reefs, how do we maintain their health in the long run? And even if we were able to maintain and preserve our coral reefs, since the world is constantly changing, how do we find new and effective ways to preserve and maintain our coral reefs not only in the Philippines, but also globally? So what is ReefPatrol? ReefPatrol is an innovative device that shows real-time data in the reef, educates the public on coral conservation, helps the government protect coral reefs from harmful actions, and eases the data gathering process, especially for scientists and researchers alike. Reef Patrol preserves coral reefs. It does this by closely monitoring the temperature, the pH, the turbidity, and the dissolved oxygen content in the surrounding waters. Studies have shown that these parameters are critical and essential in evaluating aquatic environments. Reef Patrol maintains coral reef health. It does this by helping the government regulate harmful actions against the reefs, such as dynamite fishing. It does this through online and easy to access data. And lastly, Reef Patrol finds new and effective ways of preserving and maintaining coral reefs. It does this by promoting coral reef health and education, especially to the mass public, academic institutions, and more importantly, field experts through open source data. Now, our project updates include application developments, enclosure optimizations, and printed circuit board fabrication. Now, there were numerous tweaks to the application. So firstly, we enhanced the UI so that the main screen could be easily accessed and easy to interpret. So all the data being shown in main screen can be easily seen by the user, so the user can easily swipe through the main values of the device. We also improved the application so that it's easy to use and easy to understand, and further optimizations to the menu were made through the application. Now, there were huge tweaks and optimizations to the enclosure in the case of the device. So firstly, we improved fluid dynamics and the water flowing through the sensor and the device. So we made this possible through the use of ABS. So we used a different material, and we did this especially for the mesh. So moving from a steel screen mesh, we moved to an ABS mesh. And ABS is really known for its resistance to weathering. So we also enhanced the waterproof seals in the device by the use of gaskets. So all the cables routing into the device, they all have gaskets in them. And for the first time ever, we have now a bolt and nut system. So for the first prototype, we only used shoe glue, but now we have a bolt and nut system, and this will significantly improve the rigidity and the structural integrity of the casing of the device. Now we also fabricated printed circuit board for Reef Patrol. So the first prototype we used only wires, but now we have fabricated a custom printed circuit board for Reef Patrol. So this was to make the electronics more compact and to have a minimal footprint for the device. And since we made a custom printed circuit board, having the Having minimized the traces and the trace lengths between the connections, we consequently improved signal transmission and reliability. And this also increased the electronic reliability since the distances between the connections were now smaller. Now, so far we've only used a total of 15,000 pesos. So for the 12,205, which was used to purchase the DF robot dissolved oxygen sensor, and for the 2,426 pesos, we used that money to fabricate the custom printed circuit board from JLC PCB from Shenzhen, China. So the next steps moving forward for Reef Patrol. So the first thing we plan to do is to do extensive testing for the second prototype. So we will conduct a series of multiple tests to ensure that all system prerequisites are met, and we want to test the monitoring systems and the sensors. So we want to check for three main things: data transmission, data accuracy, and data reliability. And we also want to test the gaskets and the waterproof seals that we newly inserted into the device. So we don't want the sensors being submerged in water, for example. And once we have done extensive testing for the second prototype, we want to reach out to government agencies before deployment, such as BFAR. We want them to evaluate the device, and we want to seek approval from those agencies. And once we gain approval from those agencies, we want to deploy the device. So the project development for Reef Patrol will now shift to the deployment phase. However, there are still resources needed for the further enhancement of the device. So first, we have human resources. So our goal is to have community and barangay volunteers for quick and easy field testing across multiple locations, and we plan to start in Cebu. So we plan to start in multiple locations in Cebu, and having communities and volunteers in each barangay would make field testing easier across multiple locations. We also need still financial resources. So for the developments, we believe there are still developments to be made in the enclosure and the circuitry of the device. So we want to fabricate multiple enclosures for the device, and we want to purchase low frequency radio transmission chip modules for a longer range online data transmission. So I believe that's it. This is our team and our advisor from our school. And this is done in partnership with Philippine Science High School Central Visayas Campus and with the help of Einstein Philippine Innovator Society. I believe that's it. Thank you. Thank you for the time, and we hope you have a good day. Thank you. Yes, muna. 8 minutes.